Hi, osmosis and different types of solutions. Osmosis. Once again, we'll repeat that definition. So, in short, I will write it. Okay. So, movement of the water molecules from high concentration, from high water concentration to low water concentration through a semi-permeable membrane. That is the definition we have discussed, right? Different types of solutions. What are the different types of solutions and how osmosis takes place? And I will give one daily experience or example also. Okay, use of these solutions, right? Next, types of solutions. Hypotonic solution. Hypotonic solution. Hypotonic solutions. In these solutions, the liquid part solvent will be more and solute will be little. More solvent and little solvent anamata. Next, another one is uh, isotonic. Isotonic solution. So the concentration, both the concentrations, solvent and solute, will be in equal concentrations. And then coming to last one, hypertonic. Hypertonic solution. Hypertonic solution. Here solute is more. Solute is more here. What happens if we place the cells in the three different types of solutions? First we take a hypotonic solution. Suppose I took water, I took water, I placed a cell in this water. So I placed water, a cell in this water. Suppose this is a plant cell. Okay, I placed a plant cell into this one. So some vacuole organelles are there, and in the same way I have taken a cell in the isotonic solution also. In the isotonic solution also I have taken a cell, and in this last one also we have taken one cell only. Next, one cell we have taken. Then we have to see what happens, how the movement of particles takes place in these. Okay, so how the particles move in these, we will see how osmosis takes place. What is the fate of these cells? So here hypotonic solution, I said hypotonic solutions, no? Solute, that means water is more in this medium and water content in this cell is less. When we compare the water content, water concentration in the cell is lesser and the water content in the medium, that is outside the cell, is more. According to the definition, the movement of the molecules take place from outside. See, high water concentration. So this is the high water concentration and this is the low water concentration. So the movement of molecules take place from this side outside to inside. Okay, a little bit water from outside, from inside of the cell will be passing to outside also, but overall more amount of water from outside only will be passing into the cell. What is the fate of the cell after some time? After some time we'll see the cell, after absorbing more water, after taking more water, what happens to it? It will bulge, it will bulge, it will swell. So swelling, membrane swells, stretches like this. Okay, so like this the cell size will increase, the swells, right? This is the plant cell, whereas if it is animal cell, if it is RBC, like animal cells like RBC or other cells, they too will swell and they will burst, swell and burst, swell and burst. So this process is called as hemolysis. We call this as hemolysis. Okay, so this process is called as hemolysis. And then do we use hypotonic solutions anywhere? Do we use hypotonic solutions anywhere? Yeah, hypotonic solutions, saline, right? 0.45 percentage of saline water bottles will be there. No, this saline water bottles will be injected into the body when the body cells are dehydrated. When the body cells are dehydrated. So during dehydration of the cells, when the body is dehydrated, when the cells are dehydrated, then hypotonic solutions will be injected into the body through water, through the saline bottles. That is 0.45% saline. Commonly it will be used. Okay, half normal saline we call it as. So during dehydration, this will be useful. And isotonic solutions. In this one also we placed a cell. What is the fate of this cell? So after some time, so here the water concentration outside and inside both are equal. Both are equal. So water will be moving out at the same rate. The water will be entering into the body also. Finally, what will happen? What is the fate of the cell? Thus, there is nothing change in the size of the cell. So nothing happens to the cell. No change for the cell. No change. No change. So where do we use this type of solutions? This is one example for this is Ringer's solution. Ringer's solution. This Ringer's solution is also isotonic solution. This type of solutions are mainly used to inject some medicines into the body, okay, during some conditions, medical conditions. This Ringer's reagent, the concentration of solvent in this reagent and the concentration of our body cells will be the same. So body cells concentration and Ringer's solution concentration both are same. So there will be no net loss and gain of the solvent molecules from the cell and out of the cell. So this is used to inject the solutions into the body. Okay, so this is also saline only, this is also saline only. So Ringer's solution, this is especially used for animals, animal cells. So animal cells concentration will be same as Ringer's solution. It is prepared like that. Ringer's solution is prepared like that. Hypertonic solutions. So hypertonic solutions, so what happened? Here the water content, water concentration is less, and inside the cell water concentration is high. So the water from inside the cells moves outside into the surrounding medium. Then what happens? The cells shrivel. The cells shrivel. So what happens to the cell? Cell will shrivel. So cell wall, we have taken plant cell kabatti, cell wall and cell membrane, see it shrivels like this. Whereas if it is, we call the, what happens is the they will shrink. Animal cells, they will shrink and become spiky. They will become spiky, shrink and become spiky, like spines, spiky. Animal cells, this is especially the animal cells we say. We call this process as crenation. We call this process as crenation. So cells will obviously they will die. Okay, and where is this type of hypertonic solution useful? See, gargling, mouth. When we gargle the mouth with more amount of salt in the water, that means hypotonic solutions, the bacteria present in the mouth will be dead. So the cells will lose the water content, bacterial cells will lose the water content and bacteria will die. So to kill the bacteria in the mouth, we can use the hypotonic solutions. To kill the bacteria in mouth, we can use the hypertonic solution for gargling. So this is about different types of solutions, how osmosis is taking place in different types of solutions, and then I gave one example in the daily use where this type of solutions will be useful. Thank you. We will next video animal classification I will take up. Thank you.